Hello dear students, we are going to discuss about resonance. Resonance is a phenomenon whereby the vibrating body sets the nearby body into vibration by its own natural frequency. In this, we are going to discuss about forced vibrations. Forced vibrations are vibrations which occur in a system as a result of impulses received from the nearby vibrating system. In this, we're going to discuss about the body which is forced to vibrate by another body through its own natural frequency. We are going to observe this by using a vibrating phone placed on the table. So the vibrating phone is going to force the table to vibrate by its own natural frequency. Okay, dear students, when a vibrating phone is placed on top of the table, it is going to set the table into vibration through its natural own frequency. Just observe. Resonance in a closed pipe. So let's start with the fundamental note, which is first harmonic. So this is the length of the closed pipe, and this is end correction. But the distance from this point up to this point is quarter wavelength. So therefore, for the fundamental note of first harmonic, quarter wavelength is equal to length of the closed pipe plus end correction. So wavelength is equal to 4 times brackets length of the closed pipe plus end correction. But from the definition of velocity, velocity is equal to wavelength times frequency, but this is fundamental frequency. Therefore, fundamental frequency is equal to velocity over wavelength. But wavelength is equal to 4 times brackets length of the closed pipe plus end correction. So fundamental frequency is equal to velocity over 4 brackets length of the closed pipe plus end correction. Okay, so let's see about first overturn, which is equal to second harmonic. So from here up to here is the length of this is the length of the closed pipe, but this is end correction, which will be equal to, this is half wavelength plus quarter wavelength, which is 3/4. This is 3/4 wavelength. So 3/4 wavelength is equal to length of the closed pipe plus end correction. So we have to multiply by 4. Here we are going to get 3 wavelengths is equal to 4 brackets length of the closed pipe plus end correction, divide by 3, divide by 3. Therefore, wavelength is equal to 4 brackets L plus C over 3. But the relationship between velocity is equal to wavelength times frequency, but this is the frequency of the first overturn or second harmonic. So frequency of the first overturn is equal to velocity over wavelength, but wavelength is equal to 4 times brackets length of the closed pipe plus end collection over 3. So we are going to substitute to this equation. Therefore, the frequency of the first overturn, which is equal to second harmonic, is equal to velocity over 4 brackets L plus C over 3. Therefore, frequency of the first overturn is equal to 3 times velocity over 4 brackets L plus C. But velocity over 4 brackets L plus C is equal to fundamental frequency. Therefore, this V over 4 brackets L plus C is equal to fundamental. Therefore, frequency of the first overturn is equal to 3 times fundamental. Okay, let's see the second overturn, which is equal to third harmonic. So the length from here up to this point is the length of the closed pipe, but this is the end correction. But the length from this point up to this point, this is half wavelength plus half wavelength, which is equal to 1, plus quarter wavelength, which is 1 and quarter wavelengths. So here it is 1 and quarter wavelengths is equal to length of the closed pipe plus end correction. 4 times 1 plus 1 is equal to 5 over 4 wavelengths is equal to length of the closed pipe plus end correction multiplied by 4. Here it is 5 wavelengths is equal to 4 times brackets length of the closed pipe plus end correction. Divide by 5 both sides so as to get wavelengths. So wavelengths is equal to 4 times brackets length of the closed pipe plus end correction over 5. But velocity is equal to wavelength times frequency, but this is frequency of the second overturn, which is third harmonic. So frequency of the second overturn is equal to velocity over wavelength. So, but wavelength is equal to 4 times brackets length of the closed pipe plus end collection over 5. So we are going to substitute this into this equation. So the frequency of the second overturn is equal to velocity over 4 brackets length of the closed pipe plus end correction over 5. So this will be equal to frequency of the second overturn is equal to 5 times velocity over 4 times brackets length of the closed pipe plus end correction. But velocity over 4 brackets length of the closed pipe plus C is equal to fundamental frequency. Therefore, this fundamental frequency is equal to velocity over 4 times brackets length of the closed pipe plus end correction. We're going to substitute to this equation. Therefore, frequency of the second overturn is equal to 5 fundamental frequency. Therefore, the formula for the frequency of nth harmonic is given by frequency of nth harmonic is equal to brackets 2n plus 1 brackets times fundamental frequency, whereby n is equal to 0, 1, 2, 3, 4, and so on. So n must be a whole number. So in a next presentation, we are going to solve for examples on how to use this formula. Thank you.